Okay viewers, well I'm going to do a little teardown here. So I got two identical ones of these, and this one has got a bit of damage on it. I want to repair this socket. A little bit of a crack there too. It's kind of pretty heavy, this one. I'm going to pull this one apart and see what it's like inside. If it's a C, does it use CTs or does it use a Hall sensor to detect current or whatnot. Then we can power it up. 3 phase, 4 wire, 3 times C30, 400 volt, 50 Hz, 40 to 100 amp. England, 1999. There you go, never heard of Calmu. Something hooks up in there too. Feb 01 was tested. Pretty heavy little thing there, look at that. Anyway, let's commence the teardown, see what it's like inside. Very good workbench in here again now. Anyway, getting these seals off, let's crimp them the opposite way, opposite the sides of the where it's crimped with a vice grips, nice and tight, and you can actually pull these off with a bit of careful leverage. The cable just pulls right out. Not too much damage to the meter though. Pretty ineffective bloody anti-tamper seals, but they're only there just so that you don't pull the meters apart or tamper with them. That's all they're really for. Here's the wiring connection sequence. So the communications thing in there. 4-pin connector. They cut that out of the case to fit that. It's a pretty heavy little thing. So we've got the screw left in it. Alright, let's open it up. Okay, here's what's inside this meter. The damaged RST3T port can be replaced actually. That's a good idea. I could easily fix that. Goes in there. Okay, there's a pulse lights and a receiving light. The programmer probe slides in there. Instead of having a magnet, like on the other ones, they have a magnet, you stick it on. This one actually slides on and stays in place to program it. Interesting. There's actually a spare button here too. I wonder what that does. You can't get to it on the outside. Good quality components too. It's a Panasonic capacitor, 10 microfarad, 450 volt. Yeah, that's why it's a heavy, big ass, chunky CTs in there. 1 milliohm. Pretty old school resistor. Very old school component. Backup battery. Bit of corrosion on that, but that's not because of the battery leak. That's probably just a bit of excess moisture from outside. Bleeding resistor with that capacitor. Some MOVs there. Some quality components in this thing there. Small little thing. Alright, let's fix this connector up, put it back together, give it a test. I might do a quick test to see what this button does. That's the only part that's Bakelite, that and the bottom's Bakelite and the rest is plastic. There you go. Alright, let's wire this thing up and give it a test. I'll probably wire one of the phases up just to see what it does. Okay, on one of the phases now. Another thing I noticed, typical British meter has a carry handle on it. Look at that, has its carry handle. That's cool. Turn the transformer on. It's booting up, I think. Oh, there you go. Time, the bottom dot. Okay, it tells you what does what. It's a 4:17 as a time. Hey, so I got the clock. If it stays like that, that'd be a good clock if I can't use it as a meter. That's kind of cool. It's a cool display too. You have to set it through here though, to set the time and be through there. There's no way you can set it. It turns off. Total units, 2,245 kilowatt hours. Don't know what that is. The tariff chart. 4:18 is the time. 6 of the night, 2014. Yep, that's the right time and date. Hey. There you go, that battery's fine in there. Look at that. If I look at this with the camera, and if I were to put a load through it, you'll see that impulse, because that'll be infrared in there. There must be some other communications to program it. So that will turn off. It won't stay on. They give you the readings, which is a bit unfortunate. If it stayed on, it'd be nice. What energy is a meter going to save by turning off? It's not going to save much energy at all, but it works. It's kind of cool. Let's have a look at this EDMI. I'll try to keep this intact as I can, but it's pretty interesting inside. It's got a Philips chipset in there, the Philips brains. So it's a SCC2692AE. Some up the couplers in there and everything. Oh, these things. A port of some sort. Something must plug into them, are they? They just said to protect the sockets. Must be some sort of optical communications port, I'm guessing. It's quite a nicely built unit. 23rd week of 2005. C&D Technologies component there. Let's pull this top board off. It's actually quite well made. You can see there's a bit of flux residue there. LED. Let's pull this front part off and have a good look inside. Find out why the hell these would have blown up. Possibly bad power supply issues, but for something made in Australia, why would it blow up? Hey, there's a little button there. Interesting. I'll pull it apart. Then I'll put it back together. I'll try not to destroy it too much. Put it back together. And I'll power it up with the top off and just press all these hidden buttons, see what they do. That's select LED to tell you what you selected when you're programming it, which is done through there. And that goes through to there. Shows it and receive. Opticom. Space off at 12mm. Actually quite a well made meter. Anyway, let's pull this top board off and have a good look. I guess this wasn't completely made in Australia. I think this is just assembled in Australia. I've also noticed this one's a plastic one. The rest are all identical but got ceramic Bakelite backings on them, so this might be a slightly newer one. Little buttons on there. Polyphase energy 2x16 display. There's a Chinese symbol on there. Quality control OK. 2000. 11 for the 2000. Okay, well there's must be a first design for the LCD when it first revised it. That was all the specs, how far everything's going to be spaced off and everything. But there you go. I'll keep undoing these. Some main chips there, all in sockets. Ceramic chips. And a dot in the middle there. If I expose that dot, there'll be a little square die with all wires going everywhere to connect to all these pins here. That's why some chips have a dot in the middle of them, or have a cap on the top of them. The die itself's in the middle, the chip itself. And it's got millions of little pins, hairline wires going to these pins on the outside. Okay, 2nd of the 5th, 2008. Okay, that's the firmware, version 8.28. There you go. Must be its little BIOS. Socketed TTs. Socketed device. Interesting stuff. Jumpers there, LEDs there. Undo these little standoffs, and then I'll pull this rest of this off. I think that's the backup battery. The initial W date, 26th of the 8th, 2008. That's keeping those in memory for the current tariff. Loosen these off. Yeah, didn't think these were made in Australia. It's assembled in Australia. The only real made in Australia meters are these old beasties. You don't get much more Australian than that. Undo that one. And ground 5 volt. Positive 5 volt must be it. Yeah, test point TP. It's a test point there. Carefully. Here's the back half. Look at that. Japanese capacitors in there. 1600 microfarad. 25 volt. Not a bad little quality unit. All Japanese capacitors too. Tail trans TZ76V. That's the main half. It's a power. This is your power supply half. It's got a fuse in there. That goes there, and this powers the display, the brains of it. There's a super capacitor there, or ultra capacitor actually. If you want to get real high up, and ultra capacitors are technically the ones that you can start. Technically, ultra capacitors are the ones that can start your car. It's a 5.5 volt 1 farad capacitor. There's in there, got some devices under there. Regulator there, 5 volt regulator I'm assuming. This is quality of this thing. I'm going to plug this thing in and power it up. What could possibly blow up in this thing? It's got a fuse and everything there. This thing is quality. Well, let's back it back together and power it up. You can see some chips in there. Yeah, this is just all power supply here. And the brains are here. They actually calculate the current and they work out the kilowatt hours and everything is in this half here. So that's the brains of it. Power supply at the bottom, brains, and this board here is that runs your display and does the actual communications, the receiving and transmitting of the communication half. So it's basically in 3 stages. Alright, little device there, LM399H, National Semiconductor. Be some sort of regulator or crystal or something in a package like that. I've never quite seen a package of that before. Anyway, that's the CPU, Mark III CPU card. Huh. There you go. 152003. You can plug something in there too. Anyway, let's power this thing up. The spec was right. Lowest voltage of that meter can run on 57 volts minimum, and it's running. Interesting. Hey, dot matrix display, that's cool. Manual billing, reset initiated. Whoops. What do these buttons do? Everything's right, time and date's right, kilowatt hours. 1214929, 121,000, 1,214,000. Jeez. 734,000 kilowatt hours. Done some bloody miles, this one. Max demand, 4,305 kilowatt. I like how it's got the dot matrix display though. 480,000 kilowatt hours off peak. 16:38's the time and the date. Yep, that's alright. Okay, well there's other buttons that you do. LED there. Pulsing there. If I can find some marvellous T32 things to talk to these things, it'd be nice. Well, put 10 million kilowatt hours. It's done some miles. But there you go. Actually, not too bad a meter. I do like the dot matrix displays. I would have expected that in the current smart meters, even though they're crap. That would come good for a project, a dot matrix display like that. Be good for an Arduino project. Find a way to drive the LCD, because all you got is all this here. You just find an Arduino board to connect to that and drive the LCD. Pretty much good to go. There's an anode and cathode connection there, I think. Because it's the LCD's like a bit of positive and negative, the LCD, to run the actual power of the LCD itself. Okay, 4th light. Alarm. Okay, I'll test it off. That 4th light's alarm. I triggered the alarm. Whoops. Turn the variac down. 25 volts. No. Anything lower than that it won't go. Interesting. Let's have a look at this one. It's a brand new lettuce and Gaia. This is a current production this year, this one. 14/2/59 has a date in the board, 13th week of 2013. This is a current model, so let's have a power up of this thing. Alright, let's have a good look. This is not owned by anyone, this is brand new and they just throw it out because I didn't need it. Amazing, these bloody smart meters are that consumable now. This could have been, then again, this could have been dead in the rifle, so we'll have a look. Powered straight up. 14.94 volts in C, and it was 16 volts in phase B. Must be getting creepage from somewhere. Whoa, look at that! Even has a backlight on this thing. That's cool. 6.5, 2014. 4,215 kilowatt hours. Has been used, hasn't done much though. TV set. Practically brand new, this thing. It's just a voltage of 244 volts. I'll have to hold it door. Test lamps not flashing. So 10 to 125 amps. 3 phase 4 wire. 3 times 240, 415 volt, 50 Hz class 1, 2013. I don't know if this doesn't hold, if I hold that, does it do anything? Boost? No. Offline. We know that. No, no boost. But at least these smart meters have backlights. Yeah. There we go. Bloody practically brand new, hardly used, and I throw it in the bin. Bloody crap. Power down. Click. Always got to have it a door, and that was switch mode power supplies. We're going to unplug one of a switch mode power supply, especially the charger for this camera. The pins is at me for some reason. I think I got another one of these identical. I'll have a look. If I have, check the condition of it, and I'll just cut the seal and open it up and see what it's like inside. EM5100. I wonder if this is a model that phases in for the next model after the E350 one, so that got rolled out by the government. There are a lot of similarities here, how it's constructed. Trying to break it, even though it's only a smart meter, but still. Yep, definitely current production here. Little supercapacitor, 5.5 volts, 0.18 farads. Make a bank of enough of those things, you can make a good iPod charger or iPhone charger. Under there, and I think I got to undo those. This takes this off. That'll get me to the. This is a display board. You can see we've got some isolation here. This is all the front half. You can get more isolation for the communications. To program it. That's the display half, the readout half, and the programming half all in that board, the interface module I call it. Make it easier. And under there will be the brains to process everything, and underneath that again will be the power supply. So most of all these electronic meters are all constructed the same method, in 3 stages. It's interesting to know. It's actually not quite well made for a smart meter. Very well made. The quality of components in this thing. Again, this particular meter has absolutely nothing in it. It has 2 boards. Okay. Ugh, smell that. Ugh. Got that real strong circuit board smell to it. Japanese capacitors, Panasonic's. 105 degrees Celsius rated caps. Good quality stuff. Little inductor there. On top of some sort of transformer type. I think it's a filter because the potentials go in there. And that must be a noise filter. So you get your power supply for your meter to run the brains all on this board as well. So this is your power supply here. And this runs a meter itself, and your load goes to these shunts that are around these coils here. And the maths is done all, how the meter works it out is done all on these chipsets on here. They do all the working out to determine how much you're using. The amps, the date and time and everything is all in those little, the brains there. A Garuna relay, which I think that goes to the potential, which I think, yeah, it's your boost, your hot water boost. There's nothing in this thing but the construction method, how the diodes are stepped up off the board like that is quite neat. They designed it quite well. 10th for the 7th 2012 that transformer was made. Yeah, it's a current model meter. 13th February 2013, we get a date cut on there. Chinese made relay. Takamisawa. It's a Japanese relay, but it's made in China. Cut costs. Yeah, this is all communications and programming. There's absolutely nothing in this thing. Yeah, this is pretty much the next model up, I reckon, from the E350s. So another 4 or 5 years time, when these smart meters start taking a dump and they'll replace with new smart meters, they'll be probably similar to this, but another revised version, a smarter version again. Lantis and Gaia are pretty much the leading manufacturer now of all the meters, so that's all pretty much all you'll only see these days, 90% of the time, is Lantis and Gaia. Around here anyway. Got some MOVs in there. Anyway, that concludes these teardowns. Quite well made for something Chinese, that's for sure. Anyway, thanks for watching. Another thing I just noticed, something very clever. These things here can slide back. You tighten it up and that turns the potential off. Slot it in. That just turns the meter itself off. Oh, that's a fault or troubleshooting, or if you're running it in polyphase or using it as a single phase meter or what. Not sure what really what they're used for, but that's interesting. Turns it off, turns it on. There you go. Clever.